This video covers part 2 of Trig Notes 2.5 and Pre-Calc Notes 5.5. Looking at this problem, we've done problems like this before. If I ask you to find the exact value of the sine of 165 degrees, what we were using in the past, because 165 is not on this unit circle, is we would come up with two angles we either have to add together to get 165, or that we subtract to get 165. And I could definitely use the sum and difference formulas for sine, cosine, and tangent to do this. But I want to show you another way that we can do it, which is by using the half angle formulas. So specifically, I pulled from your formula sheet the half angle formula for the sine. So if I notice that this is half of an angle that's already on the unit circle. So for example, I know that if I double this, it would become 330 degrees. So I know that I could really write it like this, that I'm really trying to find the sine of 330 divided by 2. I can use this formula here to help me find that. First thing we need to talk about is this plus or minus. You have to pick whether your answer is going to be plus or minus based upon the quadrant that you're in. 165 degrees, well that would be right about here. So in this second quadrant then, notice all my sine values are positive. So I'm going to use the positive because the sine of 165 degrees is in the second quadrant and the sine values are positive. So I have to decide whether it's positive or negative. If I was dealing with a third quadrant angle, then I would have to use the negative. So I don't really need to put that plus or minus out there anymore. I'm just going to put the plus because that's the one I'm going to use. And then I'm going to put in the square root of 1 minus the cosine of my angle. Well, notice the way that I set this up is it was 360 divided by 2. So my u, which is right here, is really the 360 degrees. I'm sorry, I said 360, I meant to say 330. So it's going to be the square root of 1 minus the cosine of 330 over 2. Alright, so all I really need to do is deal with this side, figure out what that is. So the square root of 1 minus cosine of 330 degrees is square root of 3 over 2. Then I have to divide all of that by 2. So I need to go back a little bit here and think about how do I actually subtract fractions. Well, I subtract fractions by making common denominators. So what I'm going to do, instead of writing 1 as 1, I'm just going to change it to a common denominator to make it 2 over 2. That way I can actually subtract these. It would be 2 minus the square root of 3, all over that 2 still, and then all over this 2. And again, all of this is underneath the radical. Okay, from here, next thing I want to do is deal with the fact that I have a fraction inside of a fraction. So I'm going to get rid of this 2 here. Can't just cross it off, but instead of dividing by 2, I know that I can multiply by the reciprocal, which would then leave me with the square root of 2 minus square root of 3. So when I multiply all of this by 1, it doesn't change, and 2 times 2 is 4. One more thing that I can do is recognize I'm taking the square root of a fraction, and when I take the square root of a fraction, I can write it as the square root of the numerator over the square root of the denominator. And the only thing I'm going to be able to do is simplify this by changing the square root of 4 to 2. And so that's going to be my final answer. Now, if I'm not sure if I've done this correctly, I'm going to take the time to plug this into my calculator, turn the calculator to to degree mode, and I'm going to type in the sine of 165. So I know that the sine of 165 was 0.2588, and I'm going to type all of this in, and when I do that I get the same decimal. Now remember, when you type all of this in, I wouldn't try to type it all in at once. I would figure out what 2 minus the square root of 3 is, then I'd take the square root of that, and then I'd divide that by 2. If you're not getting the same decimal, chances are you either did something wrong algebraically, or you're just typing this into the calculator wrong. So try to type it in bits and pieces instead of all at the same time. So this is definitely a way that we can work with finding the exact value of sines that are not on here. If you wanted to use the sum and difference formulas instead, because that's what we've done in section 4, feel free to do that. You don't always have to use the half angle formulas, but at least I wanted you to have some exposure with seeing it done that way. So if you have to use the half angle formula because you can't come up with two angles that add or subtract to be 165, you know how to use them. Alright, looking at this next problem, I'm trying to solve for x. The first thing that comes to my mind is I've got a sine squared and a cosine squared. And then I'm taking the cosine squared of a half angle here. So what I want to do is I want to make it be one trig function. And to do that, I'm going to use the Pythagorean identity that the sine squared of x is equal to 1 minus the cosine squared x. So I'm going to make that substitution right off the bat. So it's going to be 2 minus, then change sine squared into 1 minus cosine squared. Okay, so the next thing that I'm going to do is I'm going to manipulate this, distribute in the negative 1, 2 minus 1 plus the cosine squared of x equals, over on this side here, it's going to be 2 times, I'm going to substitute for the cosine of x over 2, I'm going to substitute this into its place, but then I still have to square it. So I'm going to give myself a big bracket there, put the squared there so I don't forget to do that afterwards, and then I'll put in the plus or minus square root of 1 plus cosine of x over 2. So algebraically now when I go to simplify this, what's nice about the fact that I had to square this is it will cancel out the square root and the plus or minus signs. And also what will happen now is because it will be 2 times 1 plus the cosine of x over 2, the 2's will also cancel each other out. Bring this down, this is 2 minus 1 is 1. So now I'm going to set my problem equal to 0 so I can factor it. So to do that, I'm going to move this over and move this over. So these two I can't subtract from each other. It becomes cosine squared minus cosine. And this is just cancels out, so 0. So if I factor, greatest common factor is a cosine. I can set these equal to 0 now. I'd have to add 1 here. So I'm going to go back to my unit circle. I'm going to look at the unit circle and come up with the angles at work here. Again, pay attention to your domain. The domain is telling you that you need to give the answer in radians one time around the unit circle, but not equal to 2 pi. So cosine of 0. The angles that have a cosine of 0 are pi over 2. And 3 pi over 2. The angles that have a cosine of 1 are 0 pi and 2 pi, but again our domain here says not equal to 2 pi, less than 2 pi, so I have to not include that one. So I've got my 3 answers here. I'd want to take the time to plug them back in to check that they work for both. And they would check it as long as your calculator is in radian mode and you are plugging these in correctly. So if you have some issues with the checking process, make sure you check in with me and I'll show you how to plug those into your calculator correctly. Okay, next problem is a little bit different because it's asking us to solve, but it says the sine of 6x, so it's 6 times an angle, and then this is the sine of 2x, so it's 2 times an angle. So I would assume, you know, the first instinct is to think about the double angles, but then this would be 3 times a double angle. So my next thought is, instead of using the double angle formulas, is to think about this as a sum to product formula. And the reason for that is because I have the sine of some angle, so let's call it the sine of u, and I'm adding to that the sine of a different angle. And that's what this formula here is showing us how to work with. So what I'm going to do is I'm going to replace it with all of this. Where in this problem the u is 6x and the v is a 2x. So I'm going to write it as 2 sine, again I'm just using this over here, of 6x plus 2x, u plus v, over 2, and then cosine of u minus v over 2. And next thing I'm going to do then is look at this and say, okay, this is going to be 2 sine of 8x divided by 2 would be 4x. This would be cosine of, let's see, 4x divided by 2 would be 2x. and then again this whole thing equals 0. So essentially what I have is I have two terms being multiplied by each other, set equal to 0, so this is one term, and this is another term. So when you have two terms being multiplied and set equal to 0, you set them individually equal to 0. And so if we solve this, we would get rid of the 2, we divide by 2, and the sine of 4x would be equal to 0. Over here, this is just the cosine of 2x is equal to 0. So what I'm going to do is I'm going to think about this as if this was just the sine of x equals 0, and if this was just the cosine of x equals 0. I'm not going to deal with double angle formulas and 2 times the double angle formulas. I'm going to go to my unit circle and I'm going to think about where is the values on the unit circle that have a sine of 0. So a sine of 0 would be at 0 pi and at pi. Okay, I could come back and I could say 2 pi, but my domain says it can't be equal to 2 pi. But remember that this is what, this is really, when I did this, this is really what 4x is equal to. Now I wrote it as x, but this is really 4x. So if my domain here is from 0 to 2 pi, my domain for 4x would be from 0 to 8 pi. I would have to multiply it by 4, and I don't want that to be equal to because it's not equal to. So if this is from 0 to 8 pi, that means I have to go around the unit circle 4 times. So this is going around the unit circle once. The second time I go around the unit circle, I'd have to add 2 pi to that. So 2 pi plus 0 would be 2 pi. And add 2 pi to that would be 3 pi. So this was 1 time around the unit circle. These were 2 times around the unit circle. A third time around the unit circle, to each of these I would add 2 pi. So that would make 4 pi. Add 2 pi to that, that's 5 pi. And then finally the fourth time around the unit circle would be adding to these 2 pi would be 6 pi and 7 pi. So now I've gone 4 times around the unit circle. But again, that's what 4x is. I don't want 4x, I want x. So I have to divide all of these by 4. And I'll list these over here then. We're going to still get 0 pi. We're going to get pi over 4. 2 pi over 4 is pi over 2. 3 pi over 4. 4 pi over 4 is just pi. 5 pi over 4. 6 pi over 4 is 3 pi over 2. And 7 pi over 4. So far, those are all the answers just for this first part of it. I still have to go through and do this for the cosine. So we're looking for x values as a cosine of 0. So cosine of 0 would be pi over 2 and 3 pi over 2. Now again, remember though, but this is really a 2x. So if this is a 2x, what I need to do is I need to change my domain. So if my domain was 2x, it would be going from 0 to 4 pi. So I need to go, this is 1 time around the unit circle, I need to go another time around the unit circle by adding 2 pi to this. So if I add 2 pi to pi over 2, I get 5 pi over 2. If I add 2 pi to that, to 3 pi over 2, I get 7 pi over 2. But, again, I'll try to kind of keep this separated here. But again, this is what 2x is. I only want what x is. So I've got to go through and divide all of these angles by 2. So doing that, pi over 2 divided by 2 is pi over 4. I've already listed that as part of my answer, so I don't have to include it again. Pi over 3 pi over 2, sorry, divided by 2 is 3 pi over 4. Again, that's already listed right there. Then this would be 5 pi over 4, which is listed right there. And this would be 7 pi over 4, which is listed there. So really I can just use this as all, these as all my answers. But I'd want to just check to make sure I didn't have anything else that wasn't repeated that I'd have to add to the list. So if you're going to do the problem this way where you don't use the double angle formulas and 2 times the double angle formulas, you have to change your domain and go a certain number of times around the unit circle. Here 4 times, here twice. And then list out all your answers.